So this is page 6 of the scheduling notes, and just a few observations from that example we just looked at. So tasks are typically infinite loops, but they need to block so that other tasks can run. So but must block so other tasks can run. And the kind of things that'll make a task block are things like OS delay, OS event flags, wait, etc. Those are the two that we've seen so far, and there will be lots more that we will see. So where I ended the demo, or the example, was we started the scheduler, so OS kernel start, and then the scheduler decides which task is going to run after that. And again, RTOS2 calls them threads. I'm just going to refer to them as tasks. That's the common terminology. So the scheduler runs the ready task with highest priority. So if both T1 and T2 are ready, then T1 would run, obviously. If there was more than one task with the highest priority that was ready, then it would do round robin scheduling, and it would give each a time slice, which is usually, for RTOS2, it's 5 milliseconds. And then it just alternates, like it just cycles through them. So if greater than 1, then it will then it does round robin, and the time slice is equal to 5 milliseconds for RTOS2. When no tasks are ready, so if you look at that example, most of the time neither task is running. Task 1 or T1 only runs when you press the push button, and T2 it'll toggle the LED on or off, and then it waits for half the period. So it's not going to take it long to toggle that LED to turn it to 0 or to 1. So it's going to spend most of its time in those delays waiting for the next change. So when no tasks are ready, the idle task runs. And this is the idle task for RTX5. So it's up to, so remember, RTX5 is the implementation, it's the kernel. RTOS2 is the API that defines what functions it needs to implement and how they should behave. So the idle thread is actually part of the RTX implementation. So OS RTX idle thread, and because it is a thread, it's got the same signature as the rest of the threads. So the return type is void, and the parameter type is a void pointer. And then it does something curious here. It casts to void the argument and then does nothing with it. So this is a valid statement, but the side effect of it, or the result of it, is not stored anywhere. So it casts argument to void and then does nothing. And so this is a trick to make a place that's convenient to set a breakpoint. So you're going to be doing debugging in lab 1. And so it gives you a place at the start of a function or the start of a task to set your breakpoint before it's actually done any of its real functionality. So convenient place for a breakpoint. So it's actually a student last term that told me about that. I had never seen it before. And this is one strange looking loop. It's valid C syntax, and this is an infinite loop. And then we close off the idle thread. So the idle thread, all it does is it just executes in that infinite loop, and the for loop body does nothing. It's empty. It is possible to set up the idle thread so that it actually puts the processor to sleep, but we're not doing that in this course. And lastly, RTOS to priorities. So we're going to draw a number line of sorts. And I'm going to divide it into 6 marks, I guess 5 segments. So at the left end here, we have OS priority idle, and it has a value of 1, and let's hope I did that about right. These next hashes are just going to be multiples of 8. And 8 is OS priority low. I'm just going to have to alternate up and down here. 16 is OS priority below normal, and 24 is OS priority normal, and 32 is OS priority above normal, and 40 is OS priority, I gotta squeeze this in here, real time. So this is an enum, and I'm sure that you've seen enums before. I'm not sure if you've seen that you can assign values to enumerations. So when this enum is created, and you can see this in _os2.h. So in Microvision 5 on the left hand side, if you're browsing your source tree, if you go to your main, for example, and then you expand it, you'll see _os2.h there. So you can double click that and you can actually see what's in that file. And so there's an enumeration, and it assigns a value of 1 to OS priority idle, and then the next enumeration is OS priority low, and it has a value of 8. Now what I haven't shown so far is that there are 7 levels between priority low and priority below normal, and it's true for all of these. So hope that I just did 7 hashes there. Yep. There. And so each of these hashes is a priority level. So we actually have what's that, 40, I think that's 32, including the priority idle. So the name for I'll just use a different color here. This one and this one I'll just give names to, and the rest you can figure out. So this is OS priority low 1, and this one is OS priority low 7. So that's quite a range of priorities. In the previous RTX, or I guess the previous RTOS version 1, there was only, I think it was 7 priorities total. OS priority idle you cannot assign to one of your tasks. It's reserved for the idle thread, but the rest you can.